This week we're moving into parts of aviation hazards, and specifically we're talking about turbulence, wind shear kind of hazards. Just looking at a surface map, we see all these fronts. We have a stationary front basically along the Rockies coming down. Then we have a pretty strong cold front coming southeast through the eastern half of the United States. So anywhere there's a boundary, there's got to be a change in wind direction. So if you were to look here, you can see a lot of northwest winds. And behind this one, they're more westerly. So if you were flying across this front, your winds at the surface would be more westerly ahead of the front, and then they would shift to the northwest, or even north almost. So you can see when you're going across the front that you immediately have a wind shift or wind shear impacting it. Now there are other factors that go into this, but we can look at it and see this is just PIREPs from pilots like you putting out information that other pilots can use. And this is how reports of turbulence get into the system. And you can see there's a ton of turbulence right along that front. So the front is definitely playing an impact on where the turbulence is today. Further back into the air, there may be a little bit, but there's not nearly the amount that's further east at the front. So what other factors do you look at when you're looking at where turbulence might be? Well, turbulence is constantly associated with the jet stream, especially when you're crossing it near the edges of it. So for example, here is a jet streak and probably another one over in here. So when a pilot is going across like this, we'll say, coming from Dallas to New York City, for example, you're going to cut across this jet stream at some point here. As you do, winds are going to increase rather quickly from the northwest here. So there's going to be wind shear, and because of that, there is going to be some turbulence up in this area, which we just saw on the previous map. So looking at jet streams, looking at where fronts are, can give you a good clue as to where you might have turbulence. So that's the first line, just real time what's happening. So with numerical models, we can forecast some of this and give you an estimate of where it's going to be in the next 6 to 12 hours, which is mostly what you're interested in with turbulence. You're not looking, you may have an idea you care about the next day's flight, but you're probably most concerned with the next 6 to 12 hours at most. And with this, we can also look at soundings. So I went out to Vandenberg Air Force Base. Very cold night there. Temperatures in the 50s, but just above it, if you get just about 5,000 feet off the ground, you have temperatures that are up close to 70. So very steep drop off in temperature here. Very calm, probably a clear night. And winds are light in this lower level where all this inversion is. But right above it, they start picking up and turning southwesterly, slowly increasing. So there would be some, as you're taking off from here, you're going to be passing through this inversion, and at some point you're going to hit this other air mass of warmer air. And in that transition, there is going to be some wind shear, and with it, possibly, that would be an area I would think you might have some likelihood of at least some mild turbulence. We can look at soundings all over the U.S. with this. And just taking a look, for example, at Florida. This is Jacksonville. Notice there's pretty strong west winds here. And we looked at that on the jet up here. And at the lower levels, they're out of the northwest. But at the very surface, again, there's a little weak inversion. Radiational cooling occurred overnight. So again, if you're taking off from Jacksonville, you're going to be climbing through this inversion and up into the different air mass where you have more winds. So it's interesting to me sometimes how I watch you pilots, and I don't claim to understand all you do on how your takeoff and landings paths you choose, but I've noticed at times when I'm on an airframe and it's beginning to descend through different layers, you really can pick out layers where the turbulence is going to increase based on the wind shear when you're looking at that, or whether there's an upper level front or a low pressure system going by a loft. So sometimes you can be aware of this and maybe kind of tend to get through those layers quicker. But I know a lot of it is based on the aviation reports, and that's where you all come in, providing that information. So I hope you got a little bit out of this, and let me know if you have any questions on this.